Okay, let's try another example. So here's our second order differential equation, homogeneous equation. So our characteristic, again, our characteristic equation is going to be r squared minus no derivative, right? So it's going to be 9 equals 0. So r squared minus 9 is obviously a polynomial expression. There's no GCF, but it has the special factorization, right? It's a difference of two squares, r minus 3, r plus 3. So here r is either plus 3 or minus 3. So if you want to just label r1 is going to be 3 and r2 is going to be negative 3. Okay, so let's write our solution. So y of x equals c1 e to the 3x, right, rx, so 3x c2 e to the r2x, so my r2 is negative 3x. So this is our solution, right, our general solution. But I do want to point out something that we're going to be using quite a bit, of course depending on the problem, but I want you to recall back from your trigonometric days, you guys learned about hyperbolic functions, or hopefully you've seen hyperbolic functions, which was the sine, right, sine sine hyperbolic or sinh of x, and that was equal to e to the x minus e to the negative x. That looks like not a nice x, so that's an x. All right, so just half of that, right? Or if you want to write half of, and then e to the x minus e to the negative x. And then we have our hyperbolic cosine, which is cosh of x. And again, you can write this as e to the x plus e to the negative x, right? Half of that. Or again, if you factor out the half, you just have e to the x plus e to the negative x. So whenever you have this expression, you're allowed to write sinh of x. And when you have this expression, you're allowed to write cosh of x because they're equal. The only difference, right, is the sign right here. This is minus, and here this is plus, but I mean, they should be similar. It is sine and cosine, and they're very similar curves. But I just wanted to point that out right now because later on, I mean, you can rewrite this general solution in terms of these hyperbolic functions because they involve e to, so e to the 3x. Okay, so what I want you to kind of see here is, let's see, so e to the 3x, and then you have e to the negative 3x. Well, here you have e to the x, e to the negative x, e to the x, e to the negative x. I mean, I could have had e to the 5x and e to the negative 5x. So when you see that pattern, you know, okay, I might have a hyperbolic sine or hyperbolic cosine. Okay, so I'm at 3 minutes. Okay, so I'll stop here, and then I'm going to do, so I've been doing a lot of general solutions. So the next problem I'm going to do in the next video is going to be solving an initial value problem. So again, given a differential equation, we're going to find a particular solution because we're given a specific condition, right, an initial condition. So we're going to be finding our C1 and C2s.